I'm Dr. John Weidner, and I know alternative energy. Alternative energy is a combination of lots of ways we can get energy in a renewable way. Wind, solar, geothermal. In all those, it's very sustainable, unlike fossil fuels, which will eventually run out. And we need to find ways of getting energy that we can sustain for hundreds or thousands of years. My area of research is electrochemistry, combines chemical energy and electrical energy in a field that studies the conversion of one to the other. So we take chemical energy, whether it's from the sun or from water, and we study how we can convert that to electrical energy, or from electrical energy to chemical energy. So a good example is wind and solar energy can be converted to electricity. What my group looks at is taking that electricity from solar or wind energy and converting it and storing it in a way that can be used later on. One of the problems with alternative energy is the sun doesn't always shine and the wind doesn't always blow. And so we have to not only be able to convert the energy to electricity, but we need to store it for when we want to use it. And two ways that my research group looks at to store energy is in batteries. So battery is a form of electrochemistry. You take electrical energy and store it as chemicals in a battery. Or as hydrogen. You can convert the electricity into hydrogen, and that hydrogen can be stored, and then that can be converted into electricity by running it through fuel cells. So electrochemistry involves both the storage of electrical energy in the form of batteries or hydrogen, and then converting that chemical, hydrogen, back into electricity. And a fuel cell is a device that does that. A fuel cell works just like a battery. It converts chemical energy into electrical energy. To do that conversion, the difference between a fuel cell and a battery is in a fuel cell, you're continuously supplying the chemical, the fuel, in this case hydrogen. And what makes fuel cells so exciting and so advantageous is that you can separate the device, the fuel cell, from the chemical. So unlike a battery where you either have to throw it away and get a new one, or recharge the entire battery, in a fuel cell, all you have to do is add more hydrogen. So you can replace your hydrogen storage container, and when that runs out, you add a new hydrogen storage container, and the fuel, the device itself, just sits there, does the conversion. And that has a lot of advantages, especially in portable applications. You can take a lot of the chemical with you, and therefore your laptop computer or your cell phone can run for long periods of time. Or in the case of a electric vehicle, you just have to pull up to a fueling station and just add more hydrogen. You don't have to recharge the battery. So that's one disadvantage of a battery electric vehicle. It can take hours to recharge. Fuel cells, recharging the hydrogen is a much simpler process. The research for hydrogen and fuel cells is not as advanced as batteries. So battery electric vehicles and capturing alternative energy in the form of batteries is probably where we are right now, and that will be the bulk of how we capture alternative energy, store it when we need to use it. But in the future, hydrogen and fuel cells are seen as a real advantage to store large quantities of energy. And that's really what we want to do. Our world uses a tremendous amount of energy. And if we want to move from a fossil fuel consuming economy to an alternative energy economy where we take advantage of wind and solar energy, we have to store large quantities of energy. And batteries are good at storing energy, but hydrogen is really where you can store vast quantities of energy and then eventually convert that to electricity using fuel cells.